SI units, and there are 7 of them in total. Okay, these are length, mass, time, thermo, right, dynamic temperature, luminous intensity, and amount of substance. Now don't worry too much about writing these down. You have a chart that's inside your study pack. Alright, so those are the 7. Now if we go into each one and we do them separately, length is regarding the distance between 2 objects. Now for that, what we have 2 points. The first one is called the origin. If we could spell, it would be really good. The second one is called the destination. A line is literally drawn between those 2 points. The line can be anywhere. It can go at that angle. It can go downwards, go slightly up. Okay. But it is between 2 points. This is also true when it comes to a circle. With a circle, obviously we have a diameter, a radius. However, the circumference is a line. It's a linear property. Now the base unit of length, it's measured in meters, and then obviously we use a number of tools to try and do measuring. Okay, so the different types of tools. We have tapes, vernier calipers, and micrometers. Okay, the next unit of measure is mass. Now the concept of mass has been developed gradually. All right, over the centuries we've had contributions from Leonardo da Vinci. All right, we've had contributions from Galileo, and we've had contributions from Sir Isaac Newton. Sir Isaac Newton, I would say, has put in the most. Okay, because he has obviously his laws. As we move on, we'll go through them. You probably heard of some of these laws in your time in school. So, for instance, for every action, there's an equal and opposite reaction, and so on and so forth. Now, mass is measured in kilograms. And just a point of note, okay, you have 1,000 kilograms. That is equal to 1 metric ton, or as my teachers used to say, to make a difference, to annotate the difference, would be 1 tonne. You also get an imperial ton, which is a completely different weight, even though it is written as 1 ton. When you're working with these things, you need to make sure that you check the spelling. Okay, so you know which one you are actually working with. The next one you have to work with is time. And the base SI unit for that is seconds, which is put as a small s. This is when you start going into tens, all right, and powers and so on, prefixes, notations. So if you have 1 minute, that will be equal to 60 seconds. Minutes are written as that, minutes. If you have it 1 hour, 1 hour is written with a single H, not with the R. And then when you start to write it as a definition, 1 hour is equal to 3.6 times 10 to the power of 3s. Now the reason why we have 3.6, okay, is because there are 360 seconds in a minute. In an hour. Right, sorry, that's wrong. It's 3,600 seconds in an hour. So the last couple. Okay, we have electric current. That is measured in amperes. We have luminous intensity. For those not in the know, that is light. Now this is measured in candelas. Candelas are roughly the number of candles that need to be burnt, right, to get that intensity of light. We have an odd one, which is the amount of substance. And this is measured in mole. I don't know why it's measured in moles. I don't know if they go hunting for them or dig them out of the ground or whatever they are. Okay, but that is what it's measured in. Now, the very last one is temperature. And it's not just called temperature, it's called thermodynamic temperature. Now this, what you're probably used to seeing 0 degrees Fahrenheit, 0 degrees centigrade, or Celsius. Normally in the UK, if you're watching BBC News or anywhere else and they're doing the weather, they're talking in that one, in Celsius. But for thermodynamic temperatures, we're talking about Kelvin. Now what Kelvin is basically the absolute zero of every single living organism or object in the world, down to an atomic level where everything is severely frozen. Now Kelvin, the absolute zero, so if we have absolute zero, that is at minus 273. Minus 273 degrees C. Right, so that's pretty cold. Our second temperature is C, and that is Celsius. You've all done this at school. All right, it's 0 point, or absolute 0 point, is where water freezes. top end is 100 degrees, and that's where water boils. Now, just to give you some comparisons, so you can actually think about this in a more logical manner and with a comparison. We're going to import a picture and we'll shrink it down for you a little bit. Now we have Fahrenheit, we have Celsius, and we have Kelvin. The sun, pretty hot. Okay. In Fahrenheit 9,937 degrees Fahrenheit. Celsius, 5,503 degrees Fahrenheit. Kelvin, 5,776. All right. Then you have your ovens, boiling water, a desert day, high fevers, a room temperature, water freezing, helium boils. I didn't even know until recently that helium boiled, but there you go. And then you have absolute zero. These parts here, okay, I would take note of. These bits here, okay, are handy to know. So if you want to convert between Fahrenheit and Celsius, if it's Fahrenheit, if that's the temperature you have, it's 1.8 times the degrees Celsius plus 32. Now the way that you get the 1.8 is it's 9 divided by 5. For Celsius, it's easier. Degrees Celsius is equal to Fahrenheit minus 32 times 1.8.